How does Linux FHS design affect system security? Have you ever wondered how the structure of a file system can impact the security of your operating system? The Linux Filesystem Hierarchy Standard, often referred to as FHS, plays a significant role in this area. It defines a clear and consistent directory structure for Linux systems, which directly influences how security measures are implemented. The FHS organizes files based on their function, shareability, and volatility. This organization helps to isolate different types of data and system components. For example, static files like binaries and libraries are typically stored in directories such as /usr and opt. These directories can be mounted as read-only, which significantly reduces the risk of unauthorized modifications or malware infections. This setup enhances the overall integrity of the system. On the other hand, variable files that change frequently are located in var and its subdirectories, such as var log and run. By keeping these files separate, the system can apply different security measures. For instance, stricter permissions can be enforced on directories where data is more dynamic and potentially vulnerable. This targeted approach helps to protect sensitive information. User data is stored in home, which keeps user files distinct from system files. This separation minimizes the risk that a compromised user account can directly affect critical system components. It also simplifies backup and recovery processes, allowing for user-specific security settings to be applied more easily. Temporary files have their own designated areas as well. Files are stored in TMP and var TMP, with TMP usually cleared upon reboot while TMP retains files longer. This distinction helps manage the lifecycle of temporary data and limits the window for potential exploitation of vulnerabilities associated with temporary files. Moreover, the FHS encourages placing unshareable files, such as device lock files and runtime data, in directories like var lock and run. These directories are often mounted with specific security options to prevent unauthorized access or tampering. By standardizing the roles of these directories, the FHS supports the implementation of security policies like mandatory access controls. Security modules can apply rules based on directory paths consistently across different Linux distributions. From a practical standpoint, the FHS design aids system administrators in enforcing least privilege principles. It isolates critical system files from user data and allows for targeted security measures based on the function and risk profile of each directory. This structure also assists in system auditing and intrusion detection by providing predictable locations for logs and runtime data. In essence, the Linux Filesystem Hierarchy Standard enhances system security by clearly defining the roles and locations of files and directories. This organized approach to file placement is a foundational security feature that sets Linux and Unix-like operating systems apart from others.